These are important functions too. So what is a demand function? It's based on the consumer's perspective, all right, or the buyer's perspective. And it basically says the demand curve is just the graph of that model. And we're going to use linear supply and demand models. So what does it typically look like? Well, let's think about that. We always graph the price on the y-axis and the number on the x-axis. All right, so that's going to go for both of these graphs. So this is price, and this is number of units demanded, and this is number of units supplied. So let's think about the demand curve. If you had a really high priced item, do you think a lot of people are going to want it? No, eventually a price could be so high that 0 people want it. So 0 units are demanded. If that price falls a little bit, then more people are going to want it, right? So our x value, the number of units people want, gets bigger as the price gets lower. All right, and we model that curve, and eventually there's some price for which you can't even give it away. All right, and that's the maximum units demanded. That is our demand curve. So the supply curve is from the manufacturer's perspective, or the producer's perspective. Supply curve is just the model of that, and even though it says curve, it's just going to be a line for us. So what does it typically look like? Well, there's some minimum price that a producer will not bother making it if it goes beyond that minimum price. So there'll be 0 units produced for some minimum price. If people are willing to pay a little more, they're going to make a little more. If people are willing to pay a lot more, well, darn it, they're willing to make a lot more. So this is our graph here. This part of our graph we don't really care about. It doesn't really make sense. Nor does this part here. So that's what it typically looks like. Alright, so let's see a couple of problems, and there's going to be a lot of good math in these problems here. So, supply functions. Gilbert Electronics will make 10,000 flat screen monitors if the price is $140. For every decrease of $20 in price, they'll make 1,000 less monitors. Now keep in mind, we know that it's going to be price versus number of units. Alright, and we know the supply curve should look like this. Now, we want to look at this. We need how much information to determine our line. Either 2 points or 1 point in a line, 1 point in a direction, or 1 point in the slope. We have the slope here, and it's sort of hidden. So we have 1 point. Our x's is price. Our x's is number. So that's 10,000. Oops, my bad. So that's 10,000 is our x, and our price is y, so 140 goes with 10,000. There's 1 point, and then here's our slope. Change in price over change in number. So a decrease of $20 is a negative 20 change in price. They will make 1,000 less monitors, so 1,000 less is down 1,000 in number. So this is our slope. If we reduce that, we get a negative over a negative is positive. So it's like 20 over 1,000, the same as 2 over 100. That reduces to 1 over 50. So that's our slope. So find the function for the curve. We also need to find the y-intercept. So we know that this is our slope. So we just plug these in. Y minus 140 equals 1/50th x minus 10 grand. There's our function. That works. That is a sufficient function. For this, we want to find when they're going to make no monitors. So what I want to do is get this in y equals mx plus b form. I want to solve for when x is 0. So what I'm going to do is put this in y equals mx plus b. So I distribute the 1/50th, and then I add the 140 over, and we end up with y equals 1/50th x plus 340. So we have the point when x is 0, y is 340. That's right here. And then the slope goes up. So at this point, they'll make 0 units if the price is $3.43. $340. So this price range, anything less than or equal to $340, they'll make no monitors. Alright, now let's look at the demand curve here. Different scenario. Quantity demanded for these iPod alarm clocks is 48,000 when the price is $8, and $12 per unit they'll demand 32,000 units. So remember, it's price versus number. Get in the habit of labeling that right away. Alright, so we actually have 2 points, so we can find the equation of a line between 2 points. So number is our x, this is our y, so we'll say 1 and 1. And then this is our, remember, price is y, so this is our y2, this is our x2. Here are our 2 points. We have 48,000 goes with 8, and 32,000 goes with 12. So find the demand equation, assuming that it's linear, sketch a graph. So to find the demand equation, we're going to first get the change in price over change in number. That's our slope. So that will be a 12 minus 8 over a 32,000 minus 48,000, which gives us a 4 over negative 16,000, which is a negative 1 over 4,000. So there's our slope. To get our equation over a line, just use point slope form. Remember, that's our go-to formula. So we have y, I can use either one, I'll use this one. Y minus 12 equals 1 negative 1 over 4 grand times x minus 3,200. There's our equation. So what is the unit price? I'm going to get this in y equals mx plus b too. So I distribute the 1/4, so I get negative 1/4000th x, and then negative 1/4000th times negative 32 is going to be a plus. This gives us a plus 8, and I add the 12 over, and then so 8 plus 12 is 20. So there's our function. So if I want to know what unit price corresponds to a demand of 40,000 units, I'm just going to plug in 40,000 for x. So what price goes with 40,000 units? Negative 1 over 44 grand times 40,000 plus 20. That gives us a negative 10 plus 20. So that would be $10 is the price that goes with a demand of 40,000 units. Then what quantity demanded is if the price is 14. So we plug in 14 for our price, and that's going to equal negative 1/4000th times the demand plus 20. So we subtract 20 from both sides, we get negative 6 equals negative 1 over 4 grand. X, multiply both sides by negative $4,000, and we get 24,000 units are demanded when the price is $14. My bad. Now I want you to make sure that you go and do self-check exercises